give us a brief description of what the project actually entailed, Chris.
So what I can do is I can also share my screen here and you can see it. All right, so basically this is what the typical structure looks like. Johnny, at any time, man, just jump in and say whatever you want to add, eh?
Yeah, I will, for sure.
Okay, so basically the structure is made up of these sloping columns, which are basically shaped plate columns, like a kind of a plate girder. But it's not a plate girder, it's just a shaped plate columns made out of a web and two flanges. The web actually sits off center of the flanges, which is there's a few, you'll see now, as I mentioned, there's quite a few challenges for us as steel contractors with the design here. There's a lot of, the way the structure is designed, it causes warping with the welding, curving of the steel. So even with these columns, with the web being off center of the flanges, once you weld the columns up, they stand in a bow. You've got to straighten them. So that was a bit of a challenge. And then it consists of them and then these T-piece rafters, which are cut out of 305 beams. The latest ones we've done are out of bigger beams, but it's a T-section rafter, shaped also, but cut out of the beam. This in itself also causes warping. When you split that T-section, then the beam jumps like when you split it on the center, it jumps like this. We have to sort of straighten these things also in our press. It's got hangers hanging those rafters with the lip channels and the gutters, so they get sheeted on top. And then I think probably the most complex part of the job for us was this, what they call the blue frame. It's just nicknamed the blue frame because it gets painted blue and the columns are red. But it's the facade, which is a rolled pipe all the way around. It's rolled on the ends, and it's a pipe section, and it holds a lip channel. Try and get it like that for you. It holds a lip channel runner on the two insides with all the information boards for the buses go on here. So this was quite a challenge, as you can see here. John, with your detailing experience, you'll also understand this. This is quite a challenge because you've got these pipes are bolted to the columns with this big bracket, and then all these many brackets that are welded to this pipe support this lip channel. And this lip channel is the fascia, it's the facade. That thing has to be so straight. That was our biggest challenge really on these buildings, to get this whole section nicely straight. And I mentioned with all the welding, you can see all these brackets are welded on one side of the pipe. So you can imagine what this pipe looks like after you've welded it up. And another big challenge,
that channel thickness was actually increased, to make it, to make sure that at the end it actually don't warp.
That's right. Yeah. It was like a 3 millimeter, and we increased it to a 3.5 or a 4 mil, so that it could be straight enough. And also interesting, I think Spencer would have enjoyed that. Well, you'll hear this. But on the joints of the purlin here, where it joins on the bracket, when this lip channel gets rolled in the mill, as it comes out of the mill, it just flares very slightly. I mean, you don't even know it. When it's in a building, it doesn't bother you at all, But once this was our facade, this flaring on the two ends was a problem. So what we actually did, you can see in our detailing here, the lip channels are rolled longer, over-rolled, and then we cut them off straight with our saw in our factory, so that the end is 100% cut end, There are just so many of those kind of details that we had to do to try and get these fascias 100% straight. I think from there, and then the bottom pipe you see is fixed to the concrete. It's got these shaped brackets, which gets drilled to the finished floor level of the station's floor. The architect also didn't want any grouting shown here. They wanted this plate, because it's the finishing, they wanted this plate flat on the floor. So it was very important that we leveled these columns up, that between the bracket at the top here, sorry man, this thing is now, between this bracket at the top holding the pipe, this one, and the finished floor had to be perfect, because once you put that bracket down and you drill it, the size for the glass between these brackets had to fit exactly. So there was quite a lot of planning required there. Now, the one other thing I can just mention that makes this structure quite unique, and you don't often notice it until you have to view the structure on site, is everything you see here bolts to these two columns. Well, all of them, but sets of two. And for the centers of these pipes to work, for the straightness of this to be fine, the level that those things run at, it means that these columns have to be perfectly at the right level. They have to be perfectly at the right slope. If that slope is out with 1 degree, then it messes around with everything else that bolts to it. So it was a huge challenge. We actually we brought an electronic spirit level that gives you a certain slope. We worked out what the slope of this outside flange is because it's also tapering. And that's what we gave our erector. So the columns had to be done at exactly that same. If you just change that slope, then it changes everything. I think Johnny might comment, but one of these roofs was so flat that when the slope of the column was wrong, the roof was nearly too, the runoff for the water wasn't enough, you know.
Yeah,
So,
I think also, Chris, on this model, everything is, your start is flat, but in real life, no road is less than 2%. So everything is at your start, your flat is already at an angle. And that affected the roof. So you need at least a 2% slope to drain the roofs. And for that to happen, ideally you would want a standard design to work everywhere. But because of this thing being built all over Joburg, basically, we had very steep road slopes, and therefore had to change the angle of that roof to allow for it to drain. So when you have a domino effect like in this picture, when one roof changes, all the others change. So what we did is we changed only the hanger length, and therefore at least the slope of your column stays the same. Because if you change the slope, then the setting out, everything is stuffed. So the easiest for us was to change the length of the hanger. Also, you will see these hangers right at the end, tie downs right at the end to the blue frame that Chris explained. So the main loading on these roofs is wind loading. So you can imagine that column, although it's very good in strength, in serviceability, you have a lot of deflection. And for us to stop the deflection, we had to have hangers at the edge. Now, that hanger, ideally, you would only want to have working in tension, but depending on which side the wind is blowing from, it does go into compression. And for that, we had to increase the size of those circular hollow sections to also allow for compression. The first question probably you guys would have is, why does this thing why would one come up with such a complicated structure for a BRT? And the answer is not to enter for the Steel Awards. It was in this time when everything had to be connected to an animal. So you can imagine the stadium in Mbombela, Nelspruit, that was connected to a giraffe, in the sense that the columns were the shape of a giraffe. So this is meant to resemble a porcupine, and that's why we have all these spikes going out. So I don't think the average user will know that, but you can sort of do the connection. You can make that connection. So from my side, yes, I have the same, that the plate girders, then the contract was split into two: the blue frame, which is yellow here, and then the main structure. And luckily it landed with the same contractor to install. And then the sloped I-beams is quite visually appealing, but it does make construction very difficult. And then the fact that all of these are sloped, not so easy. And what you don't see here is the concrete substructure. There is inside the structure a concrete whole concrete substructure that takes all the services. There's a battery chamber. There is so under here is typically a 1.2 meter deep trench under the structure. So there's almost a 3-month construction period before Mr. Steel fabricator can even come and install his steel columns.
yeah, actually, John, you forgot about that feature of the fact that these things go at a slope. I didn't put that in my in my well, the what you call it, motivation.
Yeah.
That was quite an important, quite a big thing, because you actually we drew every building flat like you see it here, but on site that thing follows the slope of the road. But yeah, it affected so many different things, so it was quite a challenge. But what's interesting then is nothing level, so you couldn't even tell your guys, hey, this is what it must be, this is the level, because it's just so difficult to explain it on site.
Yeah. So to the extent, so there was a roads team that came, and what is important for a BRT station, and typically for any bus station from a road user point of view, is when that bus stops next to the station, you need to be at grade when you cross into the station, so that makes it possible for you to go into the station on a wheelchair, on crouches, or a healthy person. So everything is set out from the road upwards, and the road team was already off site by the time the steel fabricator and the civil contractor arrived on site. So all of these levels had to be readjusted so that we can have a flat surface. And now, as we speak, there's a roads team going back to fix up all the levels to make sure that when you enter, it's flat. So for sure, a challenge. And there's not one, there's many of these stations, 10 of them, but not one of them is the same. They are close, but never the same.
Yeah. Chris, can you give us a little bit more insight into the fabrication process?
So yeah, look, I mentioned the fabrication of these pipe structures, the columns. That was quite simple. I think on the fabrication, it was obviously to count all the warping that I've mentioned. But if I can maybe show you this here, what was quite a challenge for us, obviously as we went as a learning curve, is this pipe that's welded with these brackets on. We were quite surprised how, you'd build this thing and you think it's fine, but 1 millimeter out here causes the bottom of this thing to be out with 3 or 4 mils, which causes the straightness of that lip channel to go like this. So we, after about 2 stations, we really had to relook at the accuracy of how we put locate these brackets all along this pipe to that, so that was really needed a lot of input. And then, yeah, I mentioned the lip channels that we, after about 4 stations, we requested to make it thicker because the thin material just simply wasn't straight enough. Yeah, and then everything was had to be at the best quality. I think the painting was another facet where the architect, when they came right in the beginning to our premises, they made it very clear that they don't want to see like blotchy painting, or sometimes when you roll on steel, it's not smooth, and they wanted this perfectly smooth finish. So we used a very good paint spec that will handle the weathering outside, being outside obviously, and also give that smooth effect. Yeah, so I think from that side, it was really just those challenges. The rest of the fabrication, I think, is pretty straightforward. But yeah, there's a lot of attention to detail that we had to do.
See, good. So maybe this is a question for both Chris and Johnny. How would you say that this project demonstrates the benefit of steel as a material?
Can you go first, Johnny?
Yeah, can I share another picture for us before we answer?
Yeah,
let us. But the Tekla model, she is pretty for sure. It's a architecture rendering. This is actually Watt Station, but it's they're all very, very much the same. Let me just see. Okay, so look, the benefits for you wouldn't have been able to construct this in concrete, certainly not for the same price, and also not to these dimensions, because you need reinforcement in. So also the timing, the specific project happens in the middle of CBD, where there's a lot of unrest. So all the fabrication that you can do off-site really helps, So the 2 benefits of using steel is, number one, the shapes that we were able to do. Also, the slenderness of the columns would not have been possible in concrete. And then the other thing is really the off-site fabrication that really helped the program.
Chris, do you want to add anything?
If I can add to that, constructability on site, as I did say, my motivation is the site was literally the size of the island that this thing sits on. So, there wasn't even really space for us to come in with trucks and cranes and the way we work next to the building the way you'd like to. So, we even had to load the steel in a sequence that the crane stands in the middle, a small little spider crane, and as the truck came in, they could erect from the truck in the sequence that they need. And, that, like Johnny said, you can only do that with steel. I think whatever the architect wanted, envisaged, it's nice to hear this story of the porcupine. I think what they want can only be done with steel. If you look at that interface between the steel and the glass, it's beautiful. You can't do that with anything else. And so I think that's just what makes steel. But I think, Denise, we say it every year, but it's a fact. When you want to do something a certain way, you can only do it with steel.
Yeah, that's good. So it kind of touches on my final question, and then I'll see if John has any other questions. What are you, Chris, most proud of on this project? And then we can hear from Johnny as well.
I think the fact that we finished.
Final invoice in.
No, it had its challenges. It had huge challenges. Johnny mentioned the unrest in the stations. It's actually been quite something to deal with, But anyway, I think what I'm proud of, and it's not to say anything about any other contractors, but they took us to see the sample buildings before. And this team between Stefanuti Stocks and us I think we built about 15 stations, were the ones that must still be erected. But the quality of these stations is just so high. I think when you walk through them, the amount of hours we've put into fixing things, straightening things, making sure that the final product that we've given the client is 100% acceptable. I think that's something that we're quite proud of, because it really is. The finishing is really done well. And there's a lot of work, interface between the glass contractors and our contractors, and it really just come together very well. And I think it's you're proud of those structures when you see them there, and I think that's the main point.
Yeah, I think the glassing is these frames, yeah. And those are again supplied by another contractor, Chris.
Yes.
And they have to fit in, so you can see if the slope roof is different to this, you'll see immediately. So the facade team is, they come in afterwards, and if Chris's team didn't do something right, you'll see immediately. So all the Lego pieces needs to tie up. From my side, from what we like about this project and why we are proud of it is, these stations are aesthetically pleasing, and it's all over Joburg, so it's copy paste in a way, but they're all unique, and the guys on site will be able to testify why. Some of them are unique because of a manual that was found at a place where we didn't want it, and some are unique because of very steep slopes, and others are unique because they were held by gunpoint while erecting. But the main thing is that the same sort of pattern is throughout the city, so you get that feeling throughout the city that this is taking you somewhere, So the bus go from station to station, and you can feel it when you drive by that you are going somewhere. The next thing that's very important for us, and why we're proud of this project, is there's a lot of money spent on many projects in this country, but very few of those projects actually benefit the really poor people in the country. And these stations are located in the hearts of Alex, in the heart of Joburg, up to Soweto. So all the poorest people of the poorest uses these or will be using these stations, and will be interacting with these structures. So this is not certainly, although there's stations in Sandton, this is meant actually for the lower class of people, and I think that's important.